So today we're starting Unit 2, which is everybody's favorite mathematical concept.
No, it's not.
Yes, it is. You'll do okay. I have faith in you. We're dealing with fractions. Remember, we have the two parts of the fraction. The top number is called the numerator, and the bottom is called the denominator. And we talked about this a little bit way back on the first day. It's really not two numbers. It's one number with two parts. A count. 3/4 means we have three of something, and a name. The 4 is like 4 inches or cows or whatever. It is what it is we're counting, what we have three of. So to understand fractions, the first thing we have to do is understand what does it mean to be a fourth. Easiest way to do that is to look at the old elementary school illustration of a pie or a pizza. We're dealing with my artistic talent, so you're lucky it looks that close to a circle. So, wow, you're all art critics now, huh? There, is that better?
Well, you gotta count like the...
So the whole idea of a fourth means it takes that whole object gets cut into 4 pieces. Or the other way to look at it is it takes 4 pieces to make one whole object. Of course, the 3 means we have 3 of those pieces. So it could also be thought of as a ratio as having 3 out of 4 parts of the whole object. Now, one of the things we're going to need to be able to do is we're going to need to be able to rename those fractions, to change their name. One of the simplest things we can do using this illustration is just take each of those slices of pizza and cut them into equal slices. Pretend those are equal slices. So let's say I take each slice here and cut it into 3 equal slices. Now, I used to have 4 total pieces to make a whole object. Now, how many pieces does it take to make a whole object? 12. Yeah, each of those 4 pieces got cut into 3 equal pieces. 4 times 3 is 12. I used to have 3 of those pieces. Now I have 9. Again, each of those 3 got cut into 3, so 3 times 3 is 9. So it's now 9/12 of a pizza. Do I have any more or less than I did before? No, it's the exact same amount. 3/4 and 9/12 are the same amount. They just look differently. So basically, all I did there was multiplied the top and bottom, the numerator and denominator, by the same number. And we can do that to rename any fraction. The key is to figure out what we want the name to be. So if I have 2/5 and I want to change that name into 30/5, I first need to figure out what do I multiply the 5 by to turn it into a 35. That's 7. So I have to multiply the 2 by 7 as well to get 14. So it's 14/35. I can go the other direction as well. I might have 48/60. Try to visualize 60 pieces to make a whole object, and having 48 of them, it's tough to visualize. The human brain has a hard time visualizing that many objects at once. But just like what we did up here, we can reverse the process and we can reduce these fractions to make them simpler. If I can multiply the top and bottom by the same thing, I can divide the top and bottom by the same thing. What can both of those numbers be divided by? 6 will work. 48 divided by 6 is 8. 60 divided by 6 is 10. Are we done? No, each of those can still be divided by 2. Give us 4/5. You were always taught that you had to find the largest number that goes into both the numerator and denominator. It's not true. You could have started out with dividing by 2 and just kept going. Oftentimes, if you find one number that you can divide them both by, as you get them smaller, it's easier to see what else they can be divided by. So we might have 15/75. What can both of those be divided by? 5 works. That gives me 3/15. Are we done? They both be divided by 3. So 1/5. Now remember when we talked about factoring a couple of classes ago, we went over those divisibility rules. 7 plus 5 is 12. Since 12 is divisible by 3, 75 is divisible by 3. So you can find that really quick for dividing by 3s. Usually I look for 5s or 10s first. Since these both end in 5, you know they can be divided by 5. So that's where I would have started as well. Or if they end in 0, you know it's divisible by 10. Then I usually look for 2s, since even numbers are easy to spot, and then I deal with the 3s. Then from there, hopefully, you can see if there's something like a 7 or an 11 that you can reduce. Another thing we can do to rename these, to reduce them, we might have 44 sevenths. We look at that, this is saying it takes 7 pieces to make one whole object. So this, obviously here we have enough pieces to make several whole objects. First step is to figure out how many whole objects we can make. It's often easier to do that, to have the number of whole objects with the pieces left over. This, the way it is written right here, is called an improper fraction. Now there's nothing wrong about it or improper about it, it's just the numerator is bigger than the denominator. We have more than enough pieces to make whole objects, we'd rather have some whole objects. To figure out how many whole things we can get from that, we would do 44 divided by 7, which would come out to be 6.285714286 approximately. I've done this type of stuff a few times before. Actually, I'm rounding it off. I could have kept going for another 20 or 25 digits if you wanted me to. But anyway, I use different numbers every time. But math is about patterns, and once you see the patterns in the calculations themselves are rather easy. So now this can tell us a couple of things. One is it tells us there's 6 whole objects, but the fact that there's something after the decimal tells us that there are pieces left over. Probably a simpler way to approach this is to do a long division with the remainder. 44 over 7 can be turned into a division problem as 44 divided by 7. 7 goes into 44. Well, we've seen it right here, 6 times. What's 6 times 7? 42, which leaves us with 2. So there are 6 whole objects with 2 of those pieces left over. So 6 and 2 sevenths left over. So if I have 28 thirds, I'll do the same thing. 28 divided by 3. 3 goes into 28 how many times? 9. 9 times 3? 27, so there's 1 left over. So that's 9 and 1/3. Notice the denominator doesn't change. It's still thirds no matter what. We can go the other direction. Let's say we have one of these that's called a mixed number. Now it's called a mixed number because it mixes whole numbers and fractions. Now this I just said is called a whole number because that's the number of whole objects we have. And the fraction is, of course, the pieces of the object, the fractional parts of the object. So let's say I have 3 and 4/5. If I want to change that back into an improper fraction, what it's asking me to do is to take these whole objects here and chop them into pieces. Well, how many pieces am I going to chop each of them into? The denominator tells me that it's 5. So 3 times 5 is 15 pieces. I had 4 of them before, so now I have 19 pieces, or 19/5. I might have 27/8. Oops. Scrap that. I'm going the other way. 5 and 3/8. What do I do with that? Turn that into an improper fraction. 5 times 8 is 40. Plus 3, 43/8. Good. Any questions? Thanks, sir. So then, let's have you guys try some. Let's reduce this fraction. $20 over 50. What's that reduce to? 2/5. Good. I made that one too easy for you.
You're thinking about making it tricky.
How about this one?
Oh, that's 6 over 10? Yeah, right?
Okay, I can divide both of them by 7. Gives me 6 over 10. That's a start. And then Jason just said divide by 2, 3/5. How about this? 4/7, I want to turn it into 49ths. What do I multiply the 7 by? 7. So this is going to be 28, because 4 times 7 is 28. Perfect. Yeah, that's what we started with, yes. Okay. How about this one? Let's turn it into a mixed number.
Doesn't work.
Sure it does. Type in 41 ABC 7 and hit equals. 5 and 6/7. 41 divided by 7, it would be 5.857142857143857 approximately. Yeah. But you're not dividing. Use the ABC key, the fraction key. 41 ABC 7 and hit equals. 5 and 6/7.
I didn't know the calculator could do that.
Oh yeah, I'll show you that once you guys get good at doing fractions. I'll show you that key a little bit more.
Pretty good fraction.
Let's have you guys try this one. Turn that into an improper fraction. 8 times 4 is 32.
32
Plus 3.
4.
Okay. Well, I think you guys are ready.
We automatically did the
Page 32 through 33 in your book, 1 through 49 the odds. Go for it.
Oh, I gotta write this down. Yeah, I got a brain buster for you.
What's that?
Oh,